Hello children, the last class we have learned about acceleration. So what did we learn? We learned that acceleration is the rate of change of velocity. So the unit of acceleration is meter per second square. This is the basic unit of acceleration. We have also learned that acceleration is zero, then the body is in uniform motion, and if acceleration is non-zero, then acceleration is positive or acceleration is negative. And if acceleration is positive, then initial velocity is smaller than the final velocity, and if acceleration is negative, then the initial velocity is greater than the final velocity. Up to this we have learnt, and today we are going to continue with uniformly accelerated motion. What does it mean? What is uniformly accelerated motion? So let us see about this. So when we talked about the uniform motion, we said that equal distances are covered in equal interval of time. Similarly, in case of acceleration also, what is acceleration? Acceleration is the velocity per unit time, right? So it is related with velocity, and earlier the speed was related with distance and time. So equal distances are covered in equal interval of time, then it was a uniform motion. Similarly, in uniform acceleration, it is equal interval of time. In equal interval of time, equal velocity is made. Let us clarify this with an example. So see this example. In this example, you can see that apple is falling on a person. So how is the apple falling on the person? Why does the apple is falling? Because of gravity, right? And Newton said that the acceleration due to gravity is 9.8 meter per second square, and it is always same. The acceleration due to gravity is always 9.8 meter per second square if it is for any object freely falling from on the earth from above, like this apple fall on the person, that is apple fell on Newton's head maybe, then this is a free fall of the object, and the acceleration got by the apple is 9.8 meter per second square. And even if it is not apple or anything, then also it will be always 9.8 meter per second square. And the motion is a straight line motion. We are always studying about straight line motion in this chapter, so we are on most of the time considering only the straight line motion. So here the acceleration due to gravity is 9.8 meter per second square. This means that the velocity of the freely falling object increases by 9.8 meter per second every second. That means in every second the velocity of the apple falling from above is increasing by 9.8 meter per second, and it is increasing uniformly. It is not like that one in the first second it is 9.8, in the second it is increasing by 10.7 meter per second. It's not like that. It's always 9.8 meter per second, and hence it is uniformly accelerated motion. So now we are capable of defining what is uniform acceleration. So what is uniform acceleration? If an object travels in a straight line and its velocity increases or decreases by equal amount in equal interval of time, then the body is said to be at uniform acceleration. सो अभी अभी हमने जाना है यूनिफॉर्मली एक्सेलरेटेड मोशन. यूनिफॉर्मली एक्सेलरेटेड मोशन या यूनिफॉर्म एक्सेलरेशन एक ही बात है, समझो. यूनिफॉर्म एक्सेलरेशन में क्या होता है, एक्सेलरेशन क्या होता है, आइदर पॉजिटिव एक्सेलरेशन हो सकता है या फिर निगेटिव एक्सेलरेशन हो सकता है, यानी डी एक्सेलरेशन हो सकता है. तो इन दोनों में से आइदर स्पीड बढ़ता जाएगा या फिर स्पीड घटता जाएगा. तो स्पीड का बढ़ना और घटना दोनों इक्वल इंटरवल में इक्वल अमाउंट में अगर हो तो वो यूनिफॉर्म एक्सेलरेशन होगा. नाउ लेट्स कम टू नॉन यूनिफॉर्म एक्सेलरेशन। नॉन यूनिफॉर्म एक्सेलरेशन तो भाई इजी ही है। ये क्यों इजी है? क्योंकि जो यूनिफॉर्म एक्सेलरेशन नहीं है वही तो नॉन यूनिफॉर्म एक्सेलरेशन होगा। तो नॉन यूनिफॉर्म एक्सेलरेशन का एग्जांपल हमें हर दिन हमेशा हर वक्त दिखाई देता ही रहता है, जैसे कि कोई गाड़ी जा रहा है कोई रास्ते में। In this case, the driver can slow down or move fast or stop or again move in a normal speed. जैसे कि होता है कोई ड्राइवर कहीं पर कहीं रुक सकता है, कहीं पर खाली रास्ता है तो थोड़ा ज़्यादा फास्ट चला देता है, कोई थोड़ा स्लो चलाता है, कोई भीड़ भाड़ जगह में बहुत स्लो कर देता है, कहीं पर कोई ब्रेक मार के रोक देता है, कुछ इस तरह। तो ये यूनिफॉर्म नहीं है, नॉन यूनिफॉर्म है। हर वक्त वो 9.8 मीटर पर सेकेंड की तरह मतलब फ्री फॉल की तरह एक ही एक्सेलरेशन में नहीं जा सकता है। वो हमेशा अपना एक्सेलरेशन चेंज करता रहता है डिपेंडिंग ऑन द सिचुएशन। सो द वेलोसिटी ऑफ द कार एट एवरी पॉइंट ऑफ द जर्नी विल बी डिफरेंट, यानी हर वक्त हर पॉइंट ऑफ टाइम में उसका वेलोसिटी अलग 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 होगा। जैसे कि हमने पहले भी पढ़ा था, हाउ कैन यू चेंज द वेलोसिटी? यू सेड दैट वी कैन चेंज द वेलोसिटी बाय चेंजिंग द स्पीड, राइट? We can change velocity by changing the direction in this way. In this case, it at every point of the road, हर रोड के किसी भी पॉइंट में, रास्ते के किसी भी पॉइंट में स्पीड बदलता रहता है। स्पीड जब बदलेगा तो वेलोसिटी भी बदलेगा। तो वेलोसिटी इसी तरह बदल जाता है और इसीलिए वो यूनिफॉर्म एक्सेलरेशन नहीं रहता है। तो इसका मतलब ये नॉन यूनिफॉर्म एक्सेलरेशन हो जाता है। सो वी कैन डिफाइन नॉन यूनिफॉर्म एक्सेलरेशन एज at every equal interval of time the velocity are different. So this is non uniform acceleration. So this was about uniformly accelerated motion and non-uniformly accelerated motion. So now we will continue with graphical representation of motion. जैसा हमने पहले भी दो ग्राफ्स बना चुके हैं कि यूनिफॉर्म मोशन में ग्राफ कैसा होता है, डिस्टेंस टाइम ग्राफ, और नॉन यूनिफॉर्म मोशन में डिस्टेंस टाइम ग्राफ कैसा होता है। तो हम इसके बारे में थोड़ा और डेप्थ में जानेंगे कि ये क्या समझाता है, ये ग्राफ हमें क्या दिखाता है। We have already come across the distance time graph. It was different for uniform motion and different for non-uniform motion. For the uniform motion we got a straight line, and for non-uniform motion we got something which is not a straight line. So this was about the distance time graph. But not only this, we are going to learn something more in it. So what is more in it? So we will now know that we can also calculate the speed at any point of the journey by just looking at the graph. Not only looking, we have to calculate also. But how we will do it? Let us see. So for uniform motion, we got a graph like this, which is a straight line. Why it becomes a straight line? Because equal distances are covered in equal interval of time. Now how can we calculate the speed from this distance time graph? So let us see here. So I will pick 2 points in this graph so that I can find the speed of the object in between 2 points. So for this I will need time and distance. So the time, you know, this is shown in the red with the red mark here, and then the distance is the s. So I have shown. So I have to know the time and distance. So at point A time is t1, at point B time is t2, and the distance at point A was I will take s1, and point B I will take s2. So clearly from this graph we will know that the length of t is t2 minus t1, and the length of s, the distance, is s2 minus s1. So now we can calculate the speed of the object. So how we will calculate the speed of the object? We already know the formula of speed, that average speed is equal to distance divided by time. So the same thing we will do here also. Now we know the formula that average speed is equal to distance by time. So we found the distance as s2 minus s1 and time as t2 minus t1. So average speed is equal to s2 minus s1 divided by t2 minus t1. That is the distance we are taking between point A and point B, and the time also we are taking between point A and point B. That's it. And using this formula only, we can find the average speed of the object by looking at the graph. Now coming to non-uniform motion, we also have looked at this type of graph, the distance time graph of non-uniform motion. It is not a straight line. The graph looks like this. We have already drawn this type of graph before. So here also you can see that the non-uniform graphs are not a straight line. That's it for non-uniform motion. So now we will go for the accelerated motion. We will draw the velocity time graph. So till now we were drawing the distance time graph, taking the distance in the y-axis and time in the x-axis. Now we are coming to the velocity time graph, and in this graph the velocity will be in the y-axis and the time will be in the x-axis. So now we will put the magnitude of velocities in the y-axis and the magnitude of time in the x-axis. That's so simple. Now what are the types of velocity time graph that we will see now? So clearly in this table you can see that we will find for uniform motion and non-uniform motion, the same that we did with the distance time graph. सो जल्दी जल्दी मैं यही बता देता हूँ कि द वेलोसिटी टाइम ग्राफ यूनिफॉर्म मोशन के लिए एक स्ट्रेट लाइन ही होता है, लेकिन वो स्ट्रेट लाइन कोई टेढ़ा स्ट्रेट लाइन नहीं होता है, वो एक्स एक्सिस के पैरेलल एक स्ट्रेट लाइन होता है, यानी टाइम के पैरेलल, टाइम का एक्सिस जो है उसके पैरेलल में कोई एक लाइन होगा, तो वो होगा वेलोसिटी टाइम ग्राफ फॉर यूनिफॉर्म मोशन. वो क्यों ऐसे होता है वी विल लर्न जस्ट आफ्टर दिस. और दूसरा है नॉन यूनिफॉर्म मोशन का वेलोसिटी टाइम ग्राफ. सो नॉन यूनिफॉर्म मोशन का भी दो पार्ट होता है, एक यूनिफॉर्मली एक्सेलरेटेड मोशन और एक है नॉन यूनिफॉर्मली एक्सेलरेटेड मोशन. हमने अभी अभी सीख लिया है यूनिफॉर्मली एक्सेलरेटेड मोशन क्या होता है और नॉन यूनिफॉर्मली एक्सेलरेटेड मोशन कैसे होता है. तो यूनिफॉर्मली एक्सेलरेटेड मोशन का हमें दो पार्ट मिलता है, एक है पॉजिटिवली एक्सेलरेटेड मोशन और दूसरा है डी एक्सेलरेटेड मोशन. दोनों का ग्राफ हमें स्ट्रेट लाइन ही मिलेगा, लेकिन वो पैरेलल टू एक्स एक्सिस नहीं होगा. और नॉन यूनिफॉर्मली एक्सेलरेटेड मोशन का ग्राफ हमें स्ट्रेट लाइन नहीं मिलेगा. सो नाउ लेट्स सी फॉर द यूनिफॉर्म मोशन व्हाट इज द ग्राफ वी गेट. We get a straight line. How do we get? Let us see. Now what happens in uniform motion? Equal distances are covered in equal interval of time. So we have done already before that the initial velocity and final velocity becomes same for uniform motion. That means at every point of the motion the body was at same speed. So the body is in a constant velocity. So the velocity of the body is same at every point of the journey. Now see here, I have the data of a constant velocity motion, that at every second the body was at the same velocity, that is 4 meter per second. So for this I will first draw the x-axis and y-axis, and in the x-axis I will take time t, and then in y-axis I will take the velocity v. Time t is in second and velocity is in meter per second. Now I will plot the points 0, 4, 1, 4, 2, 4, 3, 4, and then I will join the points with a line. I found that the line is a straight line and that is parallel to the x-axis, that is the time axis. So we have found that for a uniform motion the velocity time graph is a straight line which is parallel to the time axis. So the velocity time graph for the uniform motion is quite like this, which is parallel to the time axis. Now we will find the distance with the help of this graph. We already have the velocity in this graph and time in this graph, and we know the relation between velocity, distance and time as v is equal to s by t, or that is s is equal to vt, that is the distance is equal to the average speed into time. or the displacement is equal to velocity into time. So here I will choose 2 points, point A and point B, and I will find the distance between the two velocities, that is at point A and point B. So how to find the distance? We have already known it by the formula only. So in this graph we have taken the time t1 which was at point A and time t2 at point B. So here after joining all the points we can see that a rectangle is formed, and in this rectangle the length is the distance between A and B, which is the distance between T2 and T1. What is the distance between T2 and T1? It is T2 minus T1, and then the breadth of this rectangle is the velocity of the object, that is v. So we will consider the v as v only, and the time here will be T2 minus T1. So we know that the distance s is equal to v into t. So here v is v and t we will take T2 minus T1. So with this only we will find that the distance covered by the object is the area of this rectangle, that is the velocity into time. And how we will find it? So let us see here. We already know the formula that v is equal to s by t, or s is equal to v into t. So from this graph only we have found that time t is equal to t2 minus t1. We put the value of t in this relation, we got that s is equal to v into t2 minus t1. Now you can see in the graph that v was the breadth of the rectangle and T2 minus T1 is the length of the rectangle. So the distance S is equal to breadth into length, or length into breadth, that is the same thing. So this is the area of that rectangle. So whatever we find the area is the distance covered by that object between the points point A and point B. So this is how the velocity time graph for uniform motion looks like. Now I will give a question and in this graph only I will put the point A and point B, and then you have to find the distance between the velocities at point A and the velocity at point B. How you will find the distance? You just have to find the area of this rectangle. So you know which rectangle? Draw the rectangle, find the area of that rectangle, and that area of rectangle will only be the distance between the point A and point B. Clarification I will make here that the time t1 is 20 second, t2 is 40 second, and the velocity is constant and it is 10 meter per second. Now find the distance. And in the next class we will learn about the velocity time graph for non-uniform motion. So we have already seen in the chart that non-uniform motion velocity time graph are of two types, for uniformly accelerated motion and non-uniformly accelerated motion. And for uniformly accelerated motion also there are two different type of graph. One is for positively accelerated motion and one is for negatively accelerated motion. And how does it look like and how to find the distance from this velocity time graph, we will also learn about that in the next class. And up to the one I have taught you now, that the velocity time graph for uniform motion and how to find the distance from the graph itself, you have to do it in your copy. And everything I have taught you, you please maintain a fair copy and I will check it after the school reopens. So what did we learn today? The first thing we learned today was the uniform acceleration. In uniform acceleration we have seen that if an object travels in a straight line and its velocity increases or decreases by equal amount in equal interval of time, then the body is said to be at uniform acceleration. An example was the free fall of a body. And then we have learned about non-uniform acceleration. In non-uniform acceleration we have seen the example of a car driver. In that case it was a non-uniform acceleration because the velocity of the car at different point of time was different, and if at every interval of time the velocity becomes different, then the acceleration is a non-uniform acceleration. We have then gone to the graphical representation of motion. The first distance time graph we have already learned before. We have found that for uniform motion the graph is a straight line, and for non-uniform motion the graph is not a straight line. Then we have gone for the graphical representation of motion, that is for velocity time graph. In velocity time graph we have learned only up to the uniform motion. So up to uniform motion we have found that the graph is a straight line which is parallel to the time axis. The next class we will be learning about the graph for non-uniform motion. That's all for today. Thank you.